Okay then, so I think it's about time we kicked off then. Welcome everybody to our next edition in our Life Under Lockdown series. I'm sorry for those of you who, when choosing the title, we didn't actually mean it to be some sort of order. We meant it to be some sort of lighthearted look at our then predicament. We couldn't get together, we couldn't catch up, we couldn't have our usual series of get-together events with the members of the Internet Association of Australia to talk about the wonderful things about our internet exchange and learn from each other in person. So we're having to do it this way, and this way, let's hope we can do it in as productive a way as we were before. In some ways, there are positives about this, aren't there? We can get together from further afield at once, and hopefully we can learn from more of each other in this way rather than having to spend that awful time stuck in aeroplanes and such like. Okay, so now I'm just going to switch over to my screen now and do the official part of the welcome here. Okay, so here we are, life under lockdown. The question is, how do we survive heists, hijacks and hostages with our internet routing? So a couple of housekeeping points to begin with. As I said, we are streaming live via Facebook, and we are recording this for hopefully our website and posterity when it comes. Of course, you're all in your own homes or in whatever other location you thought to be convenient. I hope you all know where your exits are and your bathrooms and whatever other things you need, and that all of your family aren't laughing at you too hard behind your back as you cluster before your computer screen one more time again. Anyway, tonight we'll be sending out a feedback survey later on after the event to get your feedback on how this went, to ask you for more topics, for other topics that you might think are worthwhile to do. Please let us know which ones you'd like to hear. If there's any improvements that you think we should be trying out or doing things better, we always want to do things in a better, more effective way, and it is for you, our members, and for our other associates and friends. I understand we do have some of our colleagues from EuroIX joining us, and perhaps some others from around. I've certainly got some from New Zealand, so it's great to see the New Zealanders again, and of course right across Australia. So we've got staff from Perth and members from Perth and Adelaide, Melbourne. We really feel for you folks in Melbourne right now. And of course in Brisbane, Sydney, and hopefully there's some from Canberra as well. And of course, Tashi, our presenter, will be here from Queensland. I think we also had some visitors from India and some other further places afield, or perhaps Indonesia as well. So welcome. We really appreciate having you. Further into the concept about members, we're happy to have members do demos or presentations. If you want to tell us about your network or some achievements of your own, please let us know, and perhaps we'll be able to pencil those in or work one of those talks or presentations into our schedule as well. Or maybe even the good old peering socials. Maybe we should be all putting our AS numbers up on the screen and welcoming each other to our networks. Okay, yeah, let us know about it. The speakers we've got tonight, I have to tell you about, are just great. I'm really pleased to have Tashi Funchscho speaking to us from APNIC. He's a senior network analyst and training delivery manager at APNIC, and he's been working in the industry since 2003. Did his undergraduate studies in electrical and electronics engineering in India, then did research in next generation networks in Japan. I have to ask you who you're working with later, Tashi, and postgraduate studies in network systems in Australia here. So that's great. He's currently involved in capacity development in the APNIC community, providing technical assistance and training in a number of technical areas such as routing, network design, IXP design and deployment, network security, IPv6 deployment, DNSSEC, and of course, RPKI. So got a lot of great experience, and it's really great for us to hear from him, I think, this evening. I think I'll hand over to Tashi now. Tashi, perhaps if you could start sharing your screen, and it's a big welcome from us here at the Internet Association of Australia. And if you could talk away. Over to you, Tashi.
Yeah, thank you so much, Narelle. Can everyone hear me clear? Am I audible?
Yeah, you look great. Yep.
Sorry, I spilled some water on the keyboard. So, um, so good evening, everyone. Good afternoon, wherever you are. I'm Tashi from APNIC. Used to run a network. Now I don't do anything. So, jumping into the subject of the day, we'll just try to look at, while securing internet routing seems straightforward, as we look into the current tools and techniques, it's filled with issues. So before I jump into the technical part, just looking at few of the headlines for this year, starting off with this not so funny incident on 1st of April from Rostelecom in Russia. So what happened here was they were leaking out more specifics that we would normally not see in the routing table, and intentionally or accidentally most of the more specifics belong to CDNs. And yeah, for a couple of hours, most of the CDN networks were not reachable. So again, a more specific hijack and a more specific leak here. I like this because people tend to rely on magic boxes like BGP optimizers in their network. So this is a typical case of a provider to provider leak. Cloudflare announcing their /21s. DQE had a magic box in their network, split the /20 into 221s. It's fine if you use it in your own network, but if you leak it out to the internet without filters, that's what happened. They propagated this to their downstream who had another upstream leaked it out to that upstream. So it's a typical case of, again, BGP being a very leaky, permissive protocol by default. And then all of a sudden, Cloudflare's network is, the best path is via Verizon through that small network. And hence Cloudflare ended up losing about 15 to 20% of their global traffic there. This is my favorite use of BGP to retire early, I suppose. 2 hours work, $18 million worth of cryptocurrency. I love this Route 53 hijack. Again, a typical case of AWS announcing a /21 for their DNS infrastructure for the AWS infrastructure, and someone leaking out 8/24s, making those paths more specific and the best path. And pretty much once I control your DNS, I pretty much control what you see. So basically they were answering queries for myetherwallet.com. And then I don't know if auto cert issue was involved or whether people were not paranoid enough to add an exception in their browser and then type in their credentials. And within 2 hours, someone managed to empty about $18 million worth of cryptocurrency, myetherwallet.com. And this one is, again, how do I put this? So with someone like Google, you don't expect them to make mistakes when it comes to BGP, but they have this auto update, filter update cycle. I don't know whether it's every 6 hours or every 8 hours. And during one of those update cycles, they ended up leaking out all the more specifics from entity OCN. And the leak did not happen in Japan. It happened in West Coast US and in West Coast US. And what happened was, all of a sudden from IIJ, the trace routes are actually from IIJ's network to entity's network. Ideally, Japan to Japan should be about 10 or 15 milliseconds. All of a sudden, because of the leak of this more specifics somewhere in the West Coast of US, the best path, even for a Japan to Japan traffic, was from Japan to West Coast US. And so it was basically to the moon and back kind of latency. And of course, the most famous one of all, PTCL, Pakistan Telecom. Pakistani government wanted them to make sure a YouTube clip wasn't accessible in Pakistan. I think the engineer did the right thing by black holing that prefix. His only mistake was assuming YouTube was just a /24. He black holed it, but he ended up announcing that to his upstream, who in this case was PCCW, who ended up propagating that to the rest of the world. And for rest of us on the internet, we thought the best path to reach YouTube was through Pakistan Telecom, and they had a black hole sitting there. And I like this attack because this then kind of let the industry come together and say, okay, these things are too frequent, these things are too easy, let's come up with a framework. And that's what gave birth to the current RPKI framework. And like it or not, we are in touch with Yasir, the guy, the engineer from Pakistan Telecom who did this, and we're helping now Pakistan Telecom with their RPKI deployment. So we're coming a full circle there. Many reasons why we see this things keep happening. By design, internet itself is a decentralized internet is a decentralized network, which means there's no reference model that I can compare against, meaning if I'm sitting in Brisbane, my view of the internet routing table looks a bit different to what someone in India might see. So I can't look at my routing table and ask someone in India so that I can compare what I see and what he or she sees, because my view of the internet depends on where I'm on the internet, right? And the fact that internet works by rumor, right? Routing basically me announcing my network information to you, you propagating that onwards to your neighbors and so forth. And we assume that everyone does it honestly, but if someone does something in the middle, then when your network information reaches someone at the other end of the internet, that information may not be the way you announced it in the first place. So routing works by rumor, right? The internet routing does not have a reference model. And whether we like it or not, Professor Steve Bellovin's RFC 3514, which is again April Fool's RFC, whether we like it or not, despite this RFC, there's no evil bit, that meaning if I receive a BGP update, there's no way I can identify that it's a bad update. A bad and a good update looks the same. Right? So that's why if we look at most of the security features we have at the moment, since it's so difficult to identify what is bad, we try to identify what is good, and anything outside that, we treat it as bad. So I'll dive into that later. Before I talk about the RPKI framework, a look at the current tools and techniques which most of us might use. Somebody wants to peer with me or buy a transit service from me. Typically, we do a legitimacy of address check. And there are a couple of ways people do that. The most common one is people looking up the WHOIS database manually, looking up and look up the WHOIS database. And if I see an INetNum object there, it gives me an indication that this resource was indeed delegated, and that particular network is the rightful holder of that resource. And in some cases, you could also see route or route 6 objects there. This letter of authority is quite new to me because I used to run Bhutan Telecom's network till 2015. We never did a letter of authority. This seems to be especially predominant in countries where the legal liabilities are quite strong. So it provides zero security. It's just that if things go wrong, me trying to save myself so that I'm not responsible if things go wrong. But I don't like letter of authorities because it provides me no security. And the third most common technique, what people would do if somebody wants to peer with me or want to buy transit from me, is I would either look up our internet routing registry database. So this database is basically where people can express their intent on how I plan to route my prefixes out to the internet. And in the old days, even I used to document it really well, my own routing policies, be it with my transit providers, be it with my downstreams, or be it with my peers. I would be documenting them. But I must confess, I used to document it once, all good, but I may not update those policies correctly. But what's important is the presence of me expressing my intent of how I plan to route my V4 or V6 prefix to the global internet. In this example, I'm showing a route object, a V4 object, a 61.45.248/24, and I'm saying that I intend to originate this /24 from this particular ASN. So that's the kind of legitimacy of address check people would do. And the advantage of looking up IRR databases, we could actually make use of these IRR objects using RPSL tools like the old IRR tool sets, RTconfig, or new ones like BGPQ3 to auto-generate filters, be it prefix filters or AS path filters. And the idea is, since the IRR database is a place for me to express my intent on how I plan to route a particular prefix, so the logic with RPSL-based filter generation is, if the entries are there in the database, I'll accept those. And those entries that I don't find in the database are what I won't accept. So I've given here a few examples. On the leftmost side is the upper part is me trying to use BGPQ3 to auto-generate a prefix filter, but for the bird routing daemon. So this uses the bird syntax, and the lower one is for IPv6. But the problem with IRR database is there are just too many of them in the first place, and then it's not authoritative. It does not have a single authority model. That means, so for comparison, the middle snapshot that I have given is for us to compare. The first one, BGPQ3 by default points to RADB, the IRR database, RADB database. Whereas if you look at the second one, I'm trying to specify a source option. Or I'm trying to say is, yes, BGPQ3, go ahead and look up RADB, but I want you to only pull objects that were mirrored from authoritative source, in this case, the APNIC whois. So when I do use the authoritative source option, and when I generate the same filter, you can see a huge difference in the route objects that sit in the APNIC whois database versus the route objects that are sitting in RADB. And that's one of the problems of IRRDB. I am guilty for most of the routes that are on the leftmost side of the snapshot because I have forgotten my maintainer passwords. I used to, when I was running those networks, I used to create objects in RADB, but after I left PT, I forgot to clean them up, and then those are still there. Those historical records are still sitting there. And RPSL tools are quite powerful. Example, if I'm peering with someone, like in this example, I'm using Superloop because they have lots of downstream networks also. So instead of me generating granular prefix list, which might be hundreds of lines of prefix lists, so I could actually use RPSL BGPQ3, again, pointed to the IRR database. In this case, I'll look up a proxy aggregation object like your AS set objects. And then using that, I'll try to generate the AS path filter. So I already discussed on issues with IRR because it's a very risky model, because when I auto-generate my filters, just because there is no entry in that database, I will not accept that particular route. But is it because that route does not exist, or is it because the holder of that resource did not create a route object in the IRR database? And there are just too many IRR databases out there. At last count, about 24 or 25 of IRR databases out there. And on the right side is an example, right? When I look up this particular prefix, both belonging to Bhutan Telecom, in RADB, I see a route object which expects the origin to be AS17660. But if you look at the one with source APNIC, I see the same route, but with the origin of AS18024. Now, in this case, I know this because AS18024 is the access AS and 17660 is the transit AS. And even looking at the dates, the last modified date, I would tend to pick the lower route object. But that's the problem with IRR databases. There are just too many conflicting datas in that. So be careful when if you're trying to use RPSL tools to auto-generate your filters. Take care of the source option and make sure that you pick the one with the latest update. So that was looking at the current tools and techniques. And as you can see, the tools that we have currently are not perfect. So then comes in the RPKI framework. So before the RPKI framework, a typical scenario, I have simplified this so that it's easier to explain. I'm sitting here. I learn a route 240.66400/48, originated by AS17821. The upper path, I see it 3 AS hops away. And then someone originates the same prefix, but in this case, intentionally shortening the AS path so without RPKI, if I am this router, if I receive these two paths, by default, even if I rely on the BGP best path selection default algorithm, it would pick the lower one, which AS65552 tried to announce, although it's not the legitimate owner of that prefix. Just because the AS hop is shorter, I might pick that as the best path. But with the RPKI framework, what happens is all of a sudden, When RIRs delegate resources down to networks, RIRs issue a resource certificate, which binds your resources with your public key, which means you can now use your private key to pretty much sign any authority you sign. So very different to how digital certificates are used in other PKI frameworks. In other PKI frameworks, your digital certificates are basically an authentication mechanism, but in RPKI, your resource certificates are an authorization mechanism. So you create your rows using your private key. You can pretty much sign any authority you want. And from a routing perspective, the simplest form of authority would be your route origin authority, wherein you say, okay, I'm the owner of this prefix 240.664.0/32. I nominate this AS 17821 to originate this route. And my ROA also has a max length of 48, meaning I'll allow deaggregation up to /48. Those gets published to the repository. If I run a relying party tool or RPKI validator, it is supposed to fetch all those resource certificates, CRLs, manifest files, and ROAs. It validates each one of them. And the beauty of route origin validation is my cryptography stops at the validator. Once the validator has done all validated each and every ROA, it then pushes a crypto stripped version of that over RPKI to router protocol to your router. And then our BGP, eBGP speaking routers, they maintain a local copy of that in its memory, a cache, local cache. So whenever I receive a BGP update from any of my peers, before I accept it or before I decide what to do with it, I look up the ROA cache. And in this case, the upper path, I see the origin AS is 17821. The prefix is 240.664.0.0, and the prefix length is /48. The prefix is correct, the length is correct, and the origin AS is correct. My router will be tagging it as valid. And for the lower path, the lower route announcement, because the origin AS is 65552, and I'm expecting 17821, that's how we mark it as invalid. Right? So that's the RPKI framework, an overview, a very short explanation of what the RPKI framework looks like and what origin validation is all about. So from an implementation point of view, I guess the first thing before you even decide to implement would be make sure that you certify or you sign your prefixes and its origin authority. Right? So if I have this prefix 240.664.0.0/32, I'm saying, okay, I'll deaggregate it up to a /36 because I don't want to deaggregate it down to /48. I may not be announcing all of them, but I might be playing more specific load balancing in BGP down the line. So I've decided that I'll deaggregate it up to /36, and I nominate AS 45192 to be the origin AS. So the unique thing about ROAs, or this kind of digitally signing an authority for someone to originate your prefix, is only the owner of the prefix is allowed to create ROAs or sign this kind of authority. Right? So first create your ROAs for all your prefixes. And my request, when you create your ROAs, please be mindful. Try and match your ROAs. Your ROAs should be covering your actual BGP announcement. Some people in the early days, I started playing with RPKI around 2014 when I was still in BT. And what we did was very lazy approach. All our /12s and 17s, /17s and 18s V4s, we went with the max length of /24. And then all our V6s, we went from /32 to a max length of /48. But what that opens up is if somebody manages to spoof my source AS, the origin AS, and if networks are, even if networks are doing origin validation, they will see that spoofed AS attack as a valid one, because they will look at the origin AS, they'll look at my prefix, they'll look at the prefix length, and everything will look good. So that's why lately in the last couple of years, people like Job Schneiders, they have been pushing this concept of minimal ROA. Irrespective of what the RFC or the draft RFC says, I guess the message here is when you create your ROA, and if you're in the MyAPNIC portal allows you to import what you announce in BGP, because our route management system, the backend, is capable of looking up what you announce in your BGP, and it also gives you a prompt on your portal which says, do you want to import routes from BGP? So I would request everyone, if you haven't created your ROAs yet, please import your routes from BGP so that you have all the routes that you actually announce in your BGP sitting in your portal. And then if you could create ROAs corresponding to that, then we won't have accidental invalids. As you can see here, last year, around November last year, me and a colleague of mine, we started developing a tool internally wherein we look up route collectors, route views in Singapore, and then we have a couple of validators running at our own end to start tracking these invalids. And invalids due to max length, we managed to reduce it until Apricot in Melbourne this year. But again, since end of April and early May this year, we are again seeing a rapid increase in invalid max lengths. And when we look those up, the announcement is a /24, but the max length of the ROA is a /22. If it's a V6, announcement's a /48, but if you look up the ROA is created correctly with the correct origin AS. But if you look at the max length is /32 only. So those are all invalids which can be corrected by the owners of the prefixes. The other issue that we keep seeing the way people create ROAs is people who have multiple AS in their network, where even for Bhutan Telecom, we had a transit AS 17660, and we had 3 or 4 access AS. So this is what we see even in Sri Lanka, the same, Mongolia, the same. I was at NZNOG in January, and even there, when I was running the script, we could see the same, where people have multiple AS, but what they are doing is they're creating the ROAs only for the transit AS, whereas the route is actually being originated in their access AS. And when people who are doing origin validation receives those BGP updates, just because the origin AS is your access AS and your ROA shows your transit AS as the origin AS in ROA, we mark it as invalid, and it's seen as a possible hijack. But in reality, what we would see in this kind of a setup is your transit AS would probably be originating only aggregates for reachability purpose, but your more specifics would actually be originated from your access ASNs. So my request is either you'd create it based on how you announce things in BGP, and if you have too many resources, and if not one person is managing it, maybe at least replicate what you do for your transit AS, for your origin AS. And I wrote a blog post after Apricot at Melbourne, the Apricot in Melbourne, tracking this rise in invalids. So that's the first part of the implementation. Before you do anything, create your ROAs, which is basically digitally sign your route origins. Once that is done, it is published into the global repository. You can run your own validators. You can check that your ROAs all look good. It matches your BGP announcement. Then it's time for you to actually start setting up your own RPKI validator. These days, lots of options. In the early days, when we started working on RPKI, in the early days, 2013 and 14, we had only one option, which was the Dragon Research RPKI toolkit. Randy Bush and Steve Kent, they were running this. And in the last 2 or 3 years, they are not maintaining this anymore. And if there are anyone listening here who are good at coding and who would like to volunteer, please feel free to reach out to them. They're looking for volunteers who will maintain the code. And later came the RIPE validator. So you have lots of choices these days. RIPE validator, I think it's all individual preferences. I find it a bit heavy because of its Java dependency. The earlier versions, version 1 and 2, were not stable enough, but since version 3, RIPE validator is really good. It's really stable. And if you look at their 6th July update, it's a bit more stricter in terms of its validation now. Routinator, as we saw during our deployathon, RPKI deployathon at Apricot in Melbourne, Routinator just works. It's beautiful. It's easy install and forget kind of tool. Lightweight, works well. Octo RPKI from Cloudflare, Octo RPKI from Cloudflare written in Go, and they also have a separate RTR client called the Go RTR. Weird thing is I haven't seen an update since the last version 1.1.4. I haven't seen an update from them since last August, so not too sure if I want to run it. Fort from Nick.Mexico, well maintained, written in C, lightweight. But as I'll show later in the few slides, its validation compared to RIPE's validation and Routinator's validation seems to differ a bit. not too sure how we as an industry can lobby these validator vendors if they could all agree on a validation logic. And this is something I plan to submit as a POF sometimes, either for APNIC 50 or for future apricots. And if you want to know how to install them, we have a simple how-to blog post. Haven't updated those. I wrote them last year in October. So that's your validator part. So you set up your validator, lots of options, whether you want code diversity, you want to run two separate code bases, or whether you want to run the same code base, totally up to you. Now, once your validator is running, the validator needs a RTR feed to your eBGP speaking routers. Couple of options. Many people think this is the weakest link in the whole RPKI framework, because anybody who can control your validator could pretty much let you black hole any route they want. So for that reason, for me, I have always used my RTR in a plain TCP, which means I have always run validator in my own network. But there are people who are also discussing, oh, maybe I should run a validator in the cloud and then push my RTR feed. I wouldn't, I'm not too confident to outsource my security to third parties. So there are other authentication options. The most common one and easy one to set up is SSH between your validator and your router. There's MD5 authentication, of course, as usual, IPsec and TLS2. TCP authentication option, although the RFC says it should support it, I don't know of implementations, router implementations that can do TCP authentication option at the moment. So there are lots of options in terms of securing what your validator feeds your router. Right. Now, so you have set up your validator. You have decided on what to run. You have your RTR session. You have decided how to secure it. All good. Now, when it comes to how many validators should I run just one validator, or should I run more than one validator for redundancy? Please be mindful that if I'm a eBGP speaking router, if my RTR with the validator fails, then after whatever entries I have in my local RPKI cache, once they time out, and weirdly, what we found during the deployathon in Apricot was Juniper and Nokia, they have 1 hour timers. But with iOS XE, I don't know why they have a 300-second as their timer, whereas the RFC recommends a minimum of 600 seconds. So it all depends on them, and hopefully it's all configurable. So please know your platform, what platform you use. And once this times out, by default, as recommended in the RFC, the state of all the routes you have on your router then changes to not found. And if you have policies in place which prefers founds over not founds and drops invalids, then that policy might affect how the kind of routes that sit in your routing table. So hence, the best practice in the industry, based on people's experience, is people recommend you to at least deploy 2 validators, whether it's the same code base or different code base, again, totally up to you. So that's all good. Deploying 2 validator instances should not be difficult, but the problem is what we again found. So this is an observation that me and the team have observed. We presented this even at the last deployathon at Apricot. You can see in this example, I'm not using Cloudflare's Octo RPKI, but I did this on 16th of July, I think. We ran Fort, we ran RIPE version 3.1 and Routinator version 7.0.7.1 RC2, which supports RRDP support instead of pulling over rsync. Now, most of the validators, given all the trust anchors support RRDP, they'll try to pull over HTTPS. So after pulling them, you can see Fort seems to have a very loose validation logic compared to RIPE and Routinator. And it's very weird. Just a month ago, I presented at the ISOC's conference. And that time, Fort had lesser number of rowers compared to RIPE and Routinator. But after Routinator 3.1, 6th July update and RIPE 3.1 update, RIPE and Routinator seem to have a very strict validation logic compared to Fort's validation logic. And that strictness, I believe, comes from people like Jörg Schneider's, again, pushing, where the way validators work is first they pull all your resource certificates, all your CRLs, all your manifest files, and all your rowers, and then it verifies them one by one. So what people in the industry wanted was, if a manifest file has hash of, let's say, 10 rows, and if one hash fails, one of the hash check fails, I should not only void that particular row, but I should void the 9 other rows which are a part of that manifest file. And I believe Fort is not doing that at the moment, and maybe Ripe and Routinator are doing that, and hence why it explains why Ripe and Routinator has the same count of rows, whereas Fort has 9 extra rows compared to Ripe and Routinator. But in summary, what I'm trying to say here is, if I run different validators, you expect that the output would be the same because the validation logic should be the same, but turns out it is not. So what do? If I'm a router, I receive two conflicting ROA inputs from my two different validators. So I don't know what is the right approach, whether you run same validator, two instances, or you run two different validators. But we need to be wary of this differences in the validated ROA payload that we observe. And for this, I'm hopeful that if we can bring those validator vendors together in a room and do a BOF session, run a BOF session so that we can all agree on a validation logic. So let's see how we can arrange that. We'll reach out to the validator vendors. So that's the validator part done. And now on your router, it's straightforward. You just need to enable RPKI, basically configure the RTR session. So the first one is your iOS XR, where you say, okay, specify the validator IP address, whether you want to do which TCP port you want to use, and what refresh time do you want on your router. So the refresh time is basically how often do you want the router to query the validator for new data. On the top right-hand side is how you do it on a JunoOS, and right at the bottom is how you do it on a classic iOS or iOS XE. Please be, I think, since many vendors have their own implementation logic, I think it's very important, whoever deploys RPKI, that you know the defaults that your implementations come with. Like iOS XE was the first flavor I tried implementing RPKI because we had all AS1004s those days as our border routers. And it broke our network, I must say, because we didn't know that iOS XE by default does not consider invalids for BGP best path selection, whereas RFC says you should just tag, let me, the admin, decide what to do. But iOS XE was acting on my behalf. So please be careful. I think whoever implements, we should know what our platform defaults are. Once you have enabled RTR session, so your BGP router will start tagging routes as valid. We'll tag them as either not valid, not found, or invalid. Valid is if your prefix matches, your prefix length matches, and your origin AS matches, it's valid. Invalid if either the prefix length does not match or the source or the origin AS does not match, it's invalid. And not found is pretty much I receive a routing update, I don't see a ROA in the cache that I can compare against. So I say, I don't know. And that's what not found is. So what can we do once we have enabled RPKI on our routers? A couple of options. If you're just observing, you could just tag them and do nothing. Especially if I'm upstream and if I have my downstreams, I wouldn't want to decide on behalf of my downstream. So what I would be doing is I would be tagging them and I would be then propagating those across to my downstream so that they can decide what to do themselves. And even at IXPs, we were helping Myanmar IX last year to deploy RPKI at the Internet Exchange route server. And my suggestion to them was either talk to your members. If there is consensus, go ahead, drop the invalids. But if there is no consensus, maybe the route server can actually tag and then let your members decide what to do. I'm sure Nick will talk about it later. The other one is RFC 7115. About 3 or 4 years ago, the recommendation in the industry was do not drop invalids, but prefer your valids over not found over invalids. But in the last, seeing what I see in the last 1.5 years or 2 years, I wouldn't mind dropping invalids, but not just blindly drop them. At the moment, we see about 6,000 IPv4 routes in the BGP table. Out of the 830,000 routes we see are invalids. And for V6, it's about 3,000 routes. So what I would do if I were running a network would be profile my network, and look if there are sensitive flows or if there are big flows that go towards any of the destinations marked as invalid. And before dropping, maybe reach out to them and say, hey, I see your routes as invalid. We plan to drop it 2 months from now or 3 months from now. And if it was accidentally created, maybe they can correct it. But if they are not aware of it, maybe you can help them, handhold them, and then I would definitely drop invalids. So the choice is yours. Whoever runs the network, you decide what you want to do with the validation states. Some considerations. This was a question I heard at NZNOC when I was doing the tutorial there, where somebody goes, I have a collapsed border router and a core router in one router. So meaning there are default routes that are injected from my upstream, and to keep it cheap, not to have the full feed, he told me that he has some default routes sitting in the router. If you have default routes on your border routers or transit routers or peering routers, then your RPKI validation, origin validation does not make sense, because your default route will pretty much match anything. So maybe you need to be a bit careful and make sure that your border routers or peering routers do not have any default routes. Just a quick mention of AS0. AS0, even before RPKI, was reserved for non-routed networks anyway. But with the RPKI framework in the earlier RFC, AS0, I like how it's being used. It's because if you look at a ROA is a positive attestation from my side saying that me, the holder of this, owner of this prefix or this address space, I authorize this network to originate on my behalf. But the moment I see AS0 in a ROA, it is a negative attestation where me, if I have a ROA with AS0 as origin, I'm trying to tell the world that I don't mean to route this in the routing, in the global routing at the moment. So if you do see someone sending those routes, or if you do receive those routes, then it's definitely not me, the owner of the prefix, because I don't mean to route it. So it's a negative attestation. And especially I feel from a practical use point of view, I don't know if people have so much address space and they don't want to route it, but I have seen in networks like Mongolia or in Sri Lanka where people got their v6 prefixes from APNIC, but they haven't deployed v6 yet in their network. So it's just sitting there. So to those, I encourage them to create, for those v6 prefixes, at least create a row with AS0 as the origin, so that if anybody wants to hijack their prefixes, at least there is an AS0 row, and people doing origin validation can actually drop those routes. Right? And especially for internet exchanges, the biggest problem being members leaking out the IXP peering LAN prefix to the internet. So this is a good chance where IX operators can actually create AS0 ROA for their peering LAN prefix. But if you have another ROA with an AS which is other than your AS0, then that overrides it. And last year, after made a proposal to APNIC during one of the member meetings, Prop 132, where he goes, okay, initially, according to the RPKI framework, it was IANA who was supposed to create AS0 ROA for all the special use addresses, all the reserved address blocks. But after wanted APNIC and possibly other RIRs to create AS0 ROAs for those address space that are still undelegated, because we still have chunks of address spaces that we haven't delegated yet. So it's a good proposal, I feel, because that way, if people are trying to spoof us, people are trying to announce routes that are special use addresses or that haven't yet been delegated, at least people doing origin validation can see those and can drop those. So in summary, what should we all be doing? Basically, I always feel that instead of relying on a framework or a magic tool like RPKI, I feel we all can do better by just following basic BGP hygiene. RFC 7454 has very good, it is a really good document about the industry best practices. And then RFC 8212 trying to change BGP from being a very permissive, leaky protocol to by default BGP being a very strict protocol. So if you look at the headlines that I discussed before, this provider to provider leak is a typical BGP. That's how it behaves. If I'm configuring two BGP sessions parallelly without me telling it what to do, BGP would actually be leaking out routes between those two networks. So what RFC 8212 tries to propose is, unless I, as the admin of the network, explicitly define an inbound and outbound filter, if I don't define an explicit inbound filter, do not accept routes into my routing, into my BGP table, And if I have not defined an explicit outbound filter, then do not announce anything to my peers or my BGP neighbors. Job Schneiders is tracking this, and lately I saw that even iOS XE now has some form of support for RFC 8212, but it by default does not do that. It expects the admin to do it. And if you have platforms that still don't do it, maybe you can reach out to your vendors and say, hey, it needs to be RFC 8212 compliant. And even if your platform doesn't support it, I feel it's not a big problem because it's our habits, how we do it. If I'm configuring 2 parallel BGP sessions, maybe shut down the BGP session first, craft your filters, apply your inbound, outbound filters, and then you bring up the BGP session. It does the job. And as always, filter, filter, and filter. Filter your customers, filter your peers, and not just have prefix filters, also apply a prefix limit. If you look at how Google leaked out entity OCN's more specifics, normally they would receive only about 16,000 prefixes, but that day they received about 120,000 prefixes or something from entity OCN. So if they had a prefix limit, at least it would not have propagated so much and it would not have affected the whole of internet in Japan. The same applies for AES path filters, right? Apply AES path filters, and not just AES path filters, also apply AES path limit. Because internet, how deep is the internet? Jeff Houston's research have shown that internet is what, 5.7 to 6 AES deep. So sometimes we do see routes with crazy prepends, 120 prepends or 60 prepends or 70 prepends. What those people don't realize is, along with the route, I also need to save the route attributes. And in this case, your AES path attribute, which is so long, I need to save it in memory. And it makes things a bit more expensive for everyone. So we can apply that AES path limit too. And I think it's good to still use RPSL-based filtering, but with the right options selected. In this example, I'm saying, please make sure that even if you point it to any non-authoritative IRR database, make sure you select the right source option. Why I say this is the way it works is all the 5 RIR databases get mirrored to RADB, but there's no reverse syncing. So whatever route objects or route 6 objects you create in your RIR database will get automatically mirrored to other IRR databases. So you don't have to go create them in RADB or in any other DB. Please create it in your authoritative RIR database, and it'll automatically get mirrored there. Or you could do a combination of both. And I like what Job Schneiders is trying to push the industry to do, this concept of ROA to IRR, right? And the concept is, can we now all kill all our old IRR databases and instead come up with a clean authoritative IRR database where the entries, the route and route 6 objects that sit there should be based on an existing ROA. So if there is a valid ROA, we replicate that, translate that into a route or a route 6 objects. That means when I do RPSL-based filtering, I don't have to worry about my filters not being correct because the entries are not correct. So if the entries are authoritative, my filters will be accurate. Right? So you do the same with your upstreams, filter the bogans, filter any full bogans. You shouldn't be receiving routes that you shouldn't be seeing on the internet table, filter them out. Like we discussed before, create ROAs for your resources. And then once you've created ROAs, deploy your validators, and you could actually implement route origin validation where you start filtering inbound BGP updates, compare them against the ROAs that you have. So deploy origin validation, or you could join industry initiatives like MANRES. Right. So that pretty much wraps my talk. But before I wrap it up, just wanted to do a quick focus on Australia. I did this today morning. I tried to do it even, 16th or 17th of July. Few changes here and there, but in Australia, as you can see in IPv4 space, about 18,000 of the routes I see in the global routing table from Australian origins are unknown. And it's not just limited to APNIC's address space. Afrinic, ARIN, RIPE, IRIN, and even JPNIC. So IRIN and JPNIC, the 2 NIRs, one is from India, one is from Japan. So all those are unknowns. In IPv6, still a bit better. About 1,500 of the routes I see in the BGP table are unknowns. So with one of our new colleague, Dave, joining in, I hope we can reach out to our Australian members and try to get them to sign their resources. But the most interesting part is the invalid part. Under two different trust anchors, invalids for IPv4, we see 20 invalids under the APNIC trust anchor. I've tried to segregate them. Out of the 2016 are max length invalids, which can easily be corrected by the holders of those resources. 3 are origin AS, so it looks like a hijack. Again, that can be corrected, I feel, because if you dive deeper, which I'll do in the next slide, you will see that it was a mistake of transit and access AS sort of setup. And one was quite unique, where it's a mixture of origin AS and max length invalid. And under JPNIC, there was invalid origin AS. For IPv6, it's good that we see only 6 invalids in the global routing table, 4 of which are easily fixable because they are max length invalids. People are announcing 48s, but their ROAs are 32s, and 2 invalid origin As. So looking at the invalid ones, I have tried to pick only the top 5 networks. And before I go there, just a quick mention here, under the not founds, I had some notes here, but I can't see them now. Under the not founds, the top networks are TPG. About 5,000 of the routes that we see in the BGP table are all unknowns. Vodafone is the other one. So these 2 networks, I feel if these 2 networks can get their resources signed, then we should definitely see a decrease in the unknowns or not founds in Australia. So TPG and Vodafone, if you're listening in, feel free to reach out to us. We would love to talk to you and help you here. With invalids, this last slide, the focus is on invalids. Top one is IPv4, the lower one is V6. V4, as you can see, Summit Internet announcing 4/24s, but if you look at the ROA origin AS is correct, prefix is correct, but the max length is a /22, but you're announcing a 4/24. So this is invalid due to max length. So Summit Internet, all you need to do is import your BGP routes into your MyAPNIC portal and then just create ROAs. I think you might want to create one for the aggregate, a /22, if you're doing load balancing, and then create ROAs only for the 4/24s that you're announcing. The same applies to X integration. You're announcing 2/24s, but I see 2 ROAs. One is /22 to a max length of 22. The other one is /23 to a max length of 23. So I would request you to please correct your ROA, revoke the previous ROA, and then create a new ROA for 24. So what's unique here is I wanted to pick Internode and Telstra here. Internode is announcing a /16, and it's because it's invalid because of origin AS. I don't know what business relationship Internode has with entity. Entity OCN owns this prefix, 118.0.0/12 up to /24, and AS4713 is entity OCN. But Internode AS739 is announcing a /16, so it could either be a fat finger problem. Maybe Internode also has address from the 118 range, so could be a typo by one of the network guys, or I don't know, maybe it's a business relationship, but entity being very good with RPKI, I think they would have done it right. If Internode was supposed to allowed or authorized to originate, I'm sure entity would have created the ROA. So I feel this could possibly be an accidental hijack. The last one is the Telstra one, AS1221, Telstra Australia announcing a /24. But if you look at the ROA, there is a valid ROA, but it's for Telstra Global. So again, I don't know what's happening at the back end, but this is a typical case of, let's say Telstra Global is what the world sees Telstra as, AS4637, and let's say Telstra Australia is the access AS. If you're originating that from the access AS, please create your ROAs with the access AS as the nominated origin AS, right? Easily fixable again. So with V6, again, the same. Right? What's unique is the third line in V6, public DNS and hostlink. Public DNS AS134409 is announcing a /48, which belongs to hostlink. So hostlink, since you own this prefix, and if you're hosting public DNS instances in your network and you have delegated a /48 to them, please create a ROA that nominates their AS and not your AS, so that this won't be seen as invalid. that's it from me. Thank you so much. Acknowledging Randy and Jeff, of course. Thanks a lot.
Tashi, that was fascinating. That was absolutely fascinating. I'm sitting here scribbling down a whole bunch of notes. I didn't realize that you could aggregate and summarize so much in so many aspects of RPKI. It is so much more complex and yet so much more elegant than I realized. We have to put you in touch with Telstra, or at least I'm sure Tim will want to clean up some things there, but he's put some comments there in the chat, which I think are obviously very valid. Your point about two validators I thought was really interesting, because back in my telco days, it was really important that we had two different vendors running two different lots of systems, so that we would run, SS7, for argument's sake, would be running in two different, you'd run it in two different vendor implementations, so that you ran it in parallel and you had things in a redundant setup as much as possible. But if they're doing things so differently and you're going to drop things on that basis, I mean, we could be hijacking. So honestly, look, I should ask if anybody's got any seriously burning questions, but we are running behind time, and that's probably all my fault. So I think we should probably jump straight over to Nick so that he can let us know what we've got planned at the IX. And I really, really want to get member feedback from you on what we're floating today as our implementation. We have already told people that we've started, and we have already issued the fact that there are metrics available, but Nick's going to walk you through exactly what we're doing and how. And I really, really want your feedback. So Nick, I want you to take over the screen now, please, and prezzo away, mate.
Yeah.
Oh, sorry, you all know, everybody also already knows that Nick is my technical team lead, don't you? Who is responsible for implementing and running everything behind the scenes. Has a bunch of really wonderful folks reporting to him. And yeah, look, Nick's a wonderful guy, very, very on top of everything. Over to you, Nick.
Thanks, Narelle. Tashi, that was a absolutely fantastic presentation. It was really, really interesting to watch. And I want to call out a few people when we get to that point in here as well. So yeah, so I'm Nick from the Internet Association of Australia, and today we would like to announce that we are going to start looking at seriously implementing RPKI across our network. So what that means is we're going to start to look to drop in valid routes from members. We're going to look at proper route server automation as well. So I just wanted to kind of run through that a little bit. We have a bit of a timeline here, and we want to announce today that by the 1st of September, we will be dropping in valid routes completely across the IX fabric. Obviously, we would like to take some input from all of our members on this. Is there anything with this timeline that you guys don't see fit or that you would like changed? And yeah, so there's a few steps that we need to go through before we can do this. So part of it was metrics and reporting. We need to know what we're going to be dropping. Part of it was software upgrades on route servers. They're fairly old. The current code base doesn't actually support RPKI, so there's a few things we need to do there. The next biggest part was route server automation. It's a little bit tricky to deploy RPKI, and especially even AS set updates when the route servers are all somewhat manual at the moment. So metrics and reporting. The bird versions that we use don't support anything nice. They're very difficult and they don't have, well, any RPKI support at all. So we can't even tag routes and look at communities or anything like that. So I wrote a bunch of Python scripts to jump in, grab the rib, and then validate using some radix trees in Python and save that into Grafana, which gives us some nice, pretty dashboards. So I don't know what happened really here that much. I know that Vocus and Core Plus were responsible for this overnight. It looks like they've added an extra 60 routes from 9790, which was a bit of fun that are invalids. Got a quick list of them, and the second page because there's a few. If you're on this list, I will reach out to you at some point. So the route servers at the moment are running Ubuntu 16.04. We have 2 of them in each site. They're getting a little bit EOL from a software point of view right now. It's a little bit hard to implement RPKI on them when we can't. It just doesn't have code support on there. We're going to look to do a couple of upgrade windows on I think the 17th and 18th of August. And the 24th, 25th. We'll be taking each route server pair offline one at a time for each exchange and running some software upgrades on them, blah, 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 making it all work quite nicely. So the current state of automation is pretty manual. We have an operations portal. It has APIs. We ask a chatbot for config. It generates it. It sends it back pretty quickly. Yeah, it works. It's a lot of hacky Python scripts. AS set updates are manual. They're not automated. We still get emails from everybody. We still have to go and generate them and add them in. So we want to automate that. That's part of this as well. So moving forward, we'll be using a route server. It's a really cool piece of Python that generates route server configs based on YAML. We've built a bunch of scripts more hacky scripts to take our operations data from our portal, spit out the YAML that's required from a route server, generate all the configs, process all the AS sets, and deploy some configuration via SSH, running some validation commands at the same time. It's working. It's very cheerful. It takes a good 15 minutes or so, and it generates every config for every route server for every exchange that we run. Moving forward to RPKI. We've chosen to use Cloudflare's Octo RPKI and GoRTR tooling. The reason for this is because we can run the validation logic away from our route servers. We don't really want them to be processing all of the crypto, but we want to be running 2 of them in each exchange. So in theory, we're going to have 5 servers, 1 in each exchange, that will talk to all of the download all the trust anchors and process all the validation, exporting JSON. The GoRTR instances will run on each route server and just consume that JSON data. So a bit of fun testing with Bird, bit of fun testing with GoRTR. They talk to each other. It works. We drop in valids before importing them to the master table. We're going to accept unknowns and valids, obviously. And just a bit of playing around. On the left, we've got some test prefixes from, I believe, right? Yeah, I believe they're right test prefixes that we're using to validate the rowers, just to make sure that our validators is doing the correct things. On the middle one, there's a bit of config that will actually be used in production. That's basically the code for Bird on how we're actually performing the validation. And on the right is just the status of the RPKI session to the routers. I know it was nice and short and quick, but that's all I've got for everyone today.
That's fantastic. Thank you, Nick. So do we have any questions of either Nick or Tashi? I note that that prefix was actually a test prefix. So now we know there's a test prefix out there we can test on.
There's 3 of them. There's a valid, invalid, and an unknown test prefix that we can use that write specifically host as well that are there. Tashi, I've just got word from X integration. They've fixed that invalid role that you were just talking about in your slides as well.
Yep. Yeah. Yeah, Dave told me in the morning. I just wanted to use it to give people a scenario of multiple A's. Yeah.
No, sorry. Matthew Enger from X integration has just told me he's fixed it within the last few minutes.
Okay.
After listening to your presentation.
Yeah, thank you.
We don't mean to name and shame, but really to enable and promote promote people's achievements. So that's brilliant. Do we have any open questions? Well done, Matt, for doing that quick implementation. That's really good to hear and see. Someone's asked if we can get a copy of the slide decks. We will certainly do our best. I think that's fine by Tashi, and I'm pretty sure that's fine by Nick. I'm not entirely sure where we'll post them, but I expect we'll post some sort of link from our website if anything. Either way, the video should be available via Facebook or somewhere, but we'll let you know. We'll let you know. We will be doing, thanks you to everybody who's made it to almost the end. We're going to do a lucky door prize soon, so that will be important. Do we have any other questions here? I mean, my head's buzzing. I normally have 50 million questions, but I'm sort of still digesting. I really would like to know what people think of our timeline. I'm a bit twitchy about dropping things that my members tell me, and is there God honest truth? But
RPKI and everything, it's coming invalid. They're telling us it's invalid, like, because it's signed as not valid, right?
Yeah. If it's signed as not valid, then sure, we can drop it away. But if it's not signed as real, then yeah. I want to be confident that what we leave on the floor is what our members are happy for us to leave on the floor. Oh, there's a question here saying recommendations for how to approach this if the hardware in place does not support RPKI. Any questions about hardware? That's a good one, isn't it? What if you just don't have enough CPU or memory?
Can I take this? Or?
Sure, go for it, Tashi.
Yeah. So, good thing with origin validation is you don't have any cryptography on the routers, right? Your validators handle that. And lately I'm seeing quite a trend where people allow you to run validators on the router itself. I won't name the vendors, but even Cisco is following that path. I'm not a fan of that because then cryptography all of a sudden shifts to my router and it is quite resource heavy. But I like origin validation the way it is because my validator handles all the hard work, crypto work, and what my router gets is a crypto stripped version of the ROA cache. So there is no cryptography on the router side. So that should help with the resources.
Yeah, and was it NTT or was it another large telco just recently? They've announced that they're dropping in valids and they're validating, but they don't actually have RTR support on their routers. So they've got scripts that actually SSH into their router. They process it locally, build prefix lists, SSH into their router, and deploy prefix lists on their router instead of using an RTR protocol to hold that on the device. Protocol. Yeah. So that's also an option, but it's
it sounds a bit risky, doesn't it?
Yeah.
There's a lot of moving parts and a lot of things running in places where maybe it's not optimal.
Yeah. But it can be an option if you did want to enable it.
I feel maybe it's high time the industry actually asks the 5 RIRs to do something about Job Snyder's proposal of ROA to IRR. Because if that is the case, then I don't even need a validator, right? If my route and Route 6 objects are based on a valid ROA, then I can automate my filters directly looking at those route and Route 6 objects, which means I don't necessarily need to run a validator. I don't even need to enable RPKI on my router. But yeah, unless the proposal comes from the community, the RIRs are not going to do anything about it. So I'm not too sure if my colleagues from APNIC are listening and they may not like it, but I would like the community to actually submit this kind of proposals, or at least have a BOF session either at the next Apricot or at the next conference, either OSNOG or any of the NOGs. Maybe we should have a BOF where we discuss these things. One thing is try to bring the validator people together and ask them to agree on a validation logic so that the output looks the same. Second thing is to ask the RIRs, since you are the trust anchor for RPKI, maybe translate those ROAs into route and route 6 objects so that people can then automate their filters, and I don't have to deploy a validator or enable RTR on my routers.
So there's another question here is, Terry's asking if the next step is to sign AS paths.
Yeah, Terry.
Hang on a second.
Yeah, thanks, Terry, for that.
Somewhere about that, somewhere.
Yeah, BGP-sec, beautiful idea, never took off, right? Because it required my routers to remember keys of every other eBGP speaking routers on the internet. I needed to sign every path, and you can't have concept of partial adoption, because if I sign my path to my neighbor, but if my neighbor refuses to sign his announcement to his or her neighbors, then I can't do a path validation. But I like ASPA, a new proposal, which is still under draft, ASPath, ASPA, which is ASPath authorization, which models around ROA itself, where me as a downstream AS, if I have two upstreams, I can nominate my two upstreams as service provider AS, and my downstream AS, my own AS as the customer AS, and I can sign that like we sign a ROA, and that's called ASPath authorization. So that looks promising, Terry. Yeah, exactly, ASPA. So not too sure when we will see an actual implementation out there, but it looks promising compared to BGP-sec, I would say.
So there is another question in the Q&A, but I'm not quite sure how seriously to take this one from Brett. Legacy like XR 5.4. I think that's back to the hardware questions. Does anybody have any comments about that one? Or no, Nick wants to answer that one. Go for it, Nick.
Again, if your hardware doesn't support it or your software versions don't support it, you've always got that option of mangling prefix lists on the routers via SSH if you really wanted to do this. And I guess that's going to be your only option if your router doesn't support it, unless obviously you've got APIs that you can play with.
Yeah. Or the other option could be like what Nick has done with his route server. You could spin up a bird instance, give it a full feed, tag it with the community, send it across to your other routers, match that community, retag it back as valid or invalid, and you can try and act that way also. Lots of options, I think, but complicates things, more failure points.
Yeah.
Yeah, you lost me at the beginning there. It's like 3 steps forward. What? Yeah. Okay. Well, that's really. I think I should jump over to. I'm not seeing any more questions coming through, or is there? No, I'm not seeing any more questions through. So I wonder if I could jump over to Abby and ask her if she's given me the prize winners. Tonight's prize, I'm not sure if it can run RPKI or even if it can run BGP, to be honest.
It'll run BGP.
Oh, you're kidding me.
I'm not.
A couple of, we've got 3 MikroTik access point, USB access point routers available. And the winners are James Park from Eventbrite, Kieran Murphy from, sorry? Oh, he registered in Eventbrite. Okay, so James Park, and we've got Kieran Murphy from Tibra Global Services and Mike O'Connor from Jasmine Communications. You've all won a great little MikroTik, which actually I want one too. So I'm going to have to put my hat in it somehow, but I don't think it'll work. So that is really good. If we can, see if you can actually run RPKI on these little ticks. We want to know.
Maybe Router OS 7 will do that.
We don't have to go down to that hole now. We don't have to input. We don't have to work out the code and how to do it. But perhaps that'll be the next post that we need to do on our either our newsletter or a blog somewhere. Okay, then, folks. I think if we've got no more questions, we can actually switch over to. Oh, hang on, I had a couple of extra things I needed to do in the housekeeping close-up time. So let me just share that back again and press all the right buttons. Oops, here we go. Yes, our upcoming events, folks. If you enjoyed this one, hopefully you'll enjoy the next one we've got. Well, the next one we're actually going to be supporting the August Networking from Home with APNIC. And I think I've forgotten the date. Tashi, do you know the date? Or can Washif, are you still there? Can you pipe up and tell us the date? Type it into the chat so we make sure that everybody knows when it is. Otherwise, I'll have to change screens and check my diary. But yes, we're supporting the 4th of August, the Networking from Home event that is being run by APNIC. It's a great program of events. This is the last one in the series. They've been tweaked for each of the time zones so that every main time zone across the whole Asia Pac region gets a time zone that's not too ugly. So register from the APNIC website. In September, we've got our annual general meeting. That's from 3 p.m. Perth time, 5 p.m. Australian Eastern Standard Time. That's on Tuesday, the 8th of September. So those of you who are members, please come along. It's an important time. The official notice of meeting will be going out in the not too distant future with information on how to run for election for our board. If you want to do that, that would be great. Our next Life Under Lockdown session is going to be slightly different again. It will be, how good is our internet? And we've got the folks from the ACCC, the Australian regulator, the Australian Competition and Consumer Commission, talking to us about their broadband performance monitoring system. Hopefully we'll get somebody technical along too from their vendor, who will hopefully be able to do a deep dive into the mechanics of it all, or rather the electronics of it all, and let us know exactly how it works. I know that's been a little bit controversial lately, but they will. I think the ACCC will take us through the measurements that they've done over the last period of time that the system has been in place, and really give us some hard data on how well our access networks are working. So that's scheduled for Tuesday, the 22nd of September, and hopefully we'll see you all along then. Okay, so really what I want to do now is to say thank you all for coming. It's been great to see so many attendees. It really has been. We really appreciate you making the time out of your busy days, your busy lives, to get together with us and have so much information packed into you from such great presenters. Tashi and Nick, you've done a really great job. We definitely want your feedback on our implementation. If you like it, you think it's good, you think it's wonderful, we want to hear that. If you think it's ugly, if you think it'll do bad things, please tell us. We want you to give us that feedback, and we want to work with you to help you if your networks are not propagating the sort of information you should be. So we want to have a bit of social time now. The last time we had a bit of social time, we promoted everybody to panelists so that you could all see each other. This week, we, based on a little bit of feedback, we're just going to go to chat mode, and we're going to turn everybody on